Let's review the operation of EtherChannel. Now, EtherChannel, that's a topic we discussed back in your CCNA studies, and we're building up to the next video where we're going to be doing some EtherChannel troubleshooting. In this video, though, we just want to make sure everybody is up to speed on the basics of EtherChannel operation. With EtherChannel, we can use multiple links simultaneously between our switches. You see, normally, if I interconnect a couple of switches with a single link, that link could become a bottleneck as we're trying to push traffic between the switches. But if I were to add a second link, by default with a spanning tree protocol, we would only be sending traffic over one of those links, because a spanning tree protocol would be blocking traffic over the other link, so we didn't have a layer 2 topological loop. What we can do though with EtherChannel is logically bundle together multiple links. Typically it's in powers of 2. We can bundle together 2 or 4 or 8 links into an EtherChannel. And that little oval symbol you see over those 2 links, that indicates this is now an EtherChannel, which means we can simultaneously be sending traffic over both of those links. So this is going to give us some benefits. For example, this is going to give us higher effective bandwidth between our switches while giving us load balancing. And even though spanning tree protocol was great because it gave us redundancy, this does too. This also gives us redundant links, because if we lose one or more links in the ether channel, the remaining links in the ether channel continue operating. And we can configure EtherChannel in a few different ways. We can just say the EtherChannel mode is on and EtherChannel is just working. Or we could use one of 2 protocols. Cisco has a protocol called the PAGP, the Port Aggregation Protocol. Or there's an industry standard called LACP, the Link Aggregation Control Protocol. And these protocols can help switches negotiate between themselves the formation of an ether channel. Think of it as being somewhat similar to DTP when we're setting up a .1Q trunk. DTP can negotiate between 2 switches. Well, same thing here. Either PAGP or LACP, they can negotiate the formation of an ether channel between our switches. But a lot of people get a false sense of security about how this load balancing works. A lot of people might envision something like this. We've got 3 servers connected off of switch B, and you might assume if PC1 is going to be sending traffic to those 3 different servers, that one time the packet would go over one link in the ether channel, and the next packet might go over the next link in the ether channel, and the next packet would go over the next link in the ether channel. That's not the way it works by default. By default, EtherChannel has a load balancing algorithm, and we can select it, and we'll talk about some of the options, but it's going to have a load balancing algorithm that's going to dictate which link we use. Let's think about this. In this ether channel, we have 4 links. How many binary bits would it take to give us 4 different combinations? 2. We could have 2 binary bits, and that gives us 4 combinations of binary digits: 00, 01, 10, 11. And we can take a look at source or destination information, or both. We can look at IP address information, MAC address information. But on a lot of Cisco Catalyst switches, the default load balancing algorithm is to look at the destination MAC address. And in this case, let's say that the destination MAC address of these servers ends, I didn't write out the entire MAC address, but that first server, the last hexadecimal digit in the MAC address, it ends in a 1. And the next MAC address ends in a 5, and the next MAC address ends in a D. Well, those look different, but if we break those hexadecimal digits down into binary and we look at the last 2 digits, look at that. They're all 01. That's right. By default, on many of our Cisco Catalyst switches, in a situation like this, even though we've got an ether channel with 4 separate links between switches A and B, we're only going to be using that second link no matter which of those 3 servers we're going to, because each of those 3 servers has a MAC address that ends in 01. So personal opinion, I don't like to use just source or destination information. And I gave a MAC address example here. It could be source or destination IP address. What I would prefer to do is use a little randomness. I like to blend together source and destination information. So I would probably use source destination IP address or source destination MAC address. What this will do, if I said source destination MAC address, that's my load balancing algorithm. In a case like that, when we were choosing the link to use, then we would look, in this case, at the last 2 bits of the source MAC address, the MAC address of PC1, and the destination MAC address of one of the servers, and we would do an exclusive OR Boolean operation. That means that this PC might be using one link to get to the servers, but another PC might be using a different link because we're including source address information, not just destination address information. So personal opinion as a best practice, I like to combine source and destination, either IP address or MAC address information in my load balancing algorithm. Now let's talk about how we can form an Ether channel. If we have a couple of Cisco Catalyst switches and we're using a PAG-P, the Port Aggregation Protocol, the Cisco proprietary protocol, what we can do is set both sides to on. And by the way, if we do that, we're not really using PAG-P. We're just saying be an Ether channel. And if we set both sides to on, that will work. We'll get an Ether channel, but on does not send any PAG-P frames because, again, we're not really running PAG-P. We just say on. We're just an Ether channel. And then just like DTP had an auto and desirable mode, we've got auto and desirable modes here, and they work the same way. If one side is set to desirable and the other side is set to auto, then the desirable side will initiate the formation of the Ether channel. It will send out the PAG-P frame, and the auto side will see that, and it will respond and say, okay, let's be an Ether channel. And you see the different combinations and permutations here on screen of what will work and what will not work. Again, the on mode is not really running PAG-P. So if the other side is set to auto or desirable, it's not going to work because we're not going to be sending any PAG-P frames to the other side. If both sides are set to auto, that's not going to work because neither side is going to initiate the formation of a channel. But any other combination, which would be one side set to auto and the other side set to desirable, or both sides set to desirable, in those situations, then yes, an Ether channel would be formed. And it's very similar with LACP. Instead of saying auto and desirable, the terminology changes. Instead of auto, we have passive. And instead of desirable, we have active. But the logic works the same. And you might wonder if there's an advantage of using one over the other, PAG-P versus LACP. They are very similar. I typically would gravitate towards LACP because it is vendor interoperable, and it might even work with some appliances that you have. Maybe, for example, you want to have an Ether channel between a Cisco wireless LAN controller and your Cisco Catalyst switch. Well, in that case, you would typically use LACP for that. And another advantage of LACP is it lets us have some additional links on standby. I mentioned that we could have Ether channels with 2 links, or 4 links, or 8 links. That's true for both PAG-P and LACP, but LACP will go a step further. It will allow us to have 8 additional links on standby in case our original 8 links fail. So we could have 16 ports if we have a lot of ports available on our Cisco Catalyst switches. We could have 16 ports available for Ether channel operation, 8 that are currently active and 8 that are in standby. And that's a review of the basic operation of Ether channel. Now in our next video, we're going to take a look at some common Ether channel troubleshooting issues and go through a troubleshooting scenario together. I'll see you there.